So bottom-up parsing is a reverse of our top-down parsing, right? So how shall we? Here we're going to learn majorly a type of parsing technique called as SR parsing, which means a shift-reduce parsing. Among that, we're going to see if there are different algorithms for implementing the parser. We're going to study SLR parsing. That means simple LR parsing. And if you remember, top-down parsing is called as LL parsing, left to right, and obtaining like leftmost derivation, starting from the start state till the graph. But it is a left to right only, but it is a obtaining rightmost derivation. So all shift reduced parsers are obtains rightmost derivation. Okay. So the bottom of parsing, starting from the concept, we shall understand this is a bit too complicated compared to your top-down parsing. Okay. Yeah. Bottom of parser corresponds to the construction of the parse tree in from the string. It doesn't start from the start state, but it starts from the string and obtains the start state. So that's why we call it as bottom-up parser. In top-down parser, we used to start with the start state, replace the non-terminal by appropriate productions until we obtain the string. But now in the bottom-up parser, we start from the string, replace a string or replace a substring by appropriate non-terminal by using a production. Means production is replaced by non-terminal. This will be repeated until the start state is obtained and all input symbols are consumed. So that's why we call it as a bottom-up parser. Fine. So we shall take one simple example. Here we have a production. G is producing E plus T, or T is producing T star F or F. F produces open parenthesis E or I. How to obtain the bottom-up parsing? Manually, we shall see. Then we go on building the parser. Fine. Have a look at this. First, and the string that we need to obtain or to be parsed is ID star ID. Let us see how it works. Start from ID star ID. We have a production wherein T is producing T star F or F. So obviously, and F is producing ID. Obviously, we can replace the ID by F. ID is a substring now. F is a non-terminal, that is replacing. So fine, ID is replaced by F. So what remains now? F star ID is replaced. So we should completely do this until we get this E. Actually, this is supposed to be E. 1 second. This is E. Okay. So this is our E. Okay. And the next step, what we'll do, we can replace the second ID also, correct? No, that ID also by F. And actually, this is not obtaining RMD. We shall see the example wherein RMD is obtained. This is, as I told you, we are doing it manually, right? The next step, what we can do, the F can be replaced by T. Why I can replace by T? Because we have a production, T produces T star F or F. So we are able to replace F by T. Okay, and we can now go and replace the other F also by T, right? So we obtained a T from this ID star ID, and we have a production. T produces, sorry, yeah, and E produces T. Getting the idea? So first we replace the ID by F. The second ID also we replaced by F. So we got F star F. Then we came to know that F can be replaced by T from the production, right? Then we replaced T star F by T, and then we replace T by E because of the production. E produces E plus T or T. So this way, we step by step replace a substring or a of the substring by its appropriate non-terminal by looking at the production. And this we did manually. This should happen automatically. So lot of challenges are there. What is that? First and foremost thing we should see, is there a valid string that can be replaced? Second thing is that which production to be chosen for replacing of the string. And there are also many different conflicts arise. We shall see how we can solve all of those things. Okay, continuing further. Here we have seen mainly two actions. Reductions means replacing a substring by its appropriate production. That's what we call it by the name Bottom-up parsing is a process of reducing a string. The name of the string we are calling it as W to start symbol of the grammar. That's what we mean by reduction. At each reduction step, specific substring matching the body of the production is replaced by a non-terminal. Right? These are a bit theoretical things. Key decision about is when to reduce. That's the first question, when to reduce. We can reduce until when we got an appropriate production that can be replaced by a non-term. And which production to use for reduction. These are the key things that will go to work. Handle pruning. We call this by the name handle pruning. The substring chosen for replacement is called as handle. So in our previous example, beginning at the very beginning stage, ID was the handle. The next state, another ID was a handle. Next state, F star, F is a handle. So among that, we have chosen only one F to replace it with T. The next stage, T star F is the handle. Next, T is the handle, like that way. Okay, handle pruning. So as we are choosing a substring to replace it with a production, sorry, replace it with a non-terminal, that's what is called as handle. So entire exercise of the bottom-up parser is choose a handle. It may be a substring or it may be an entire string, whatever it may be, but it should match to a production. That is replaced by the non-terminal in the rightmost derivation manner. Right? We should obtain the rightmost derivation. Means we should start from the rightmost non-terminal, keep on replacing until we obtain the start state. Right? Okay. Let's see the handle pruning reductions specifically in the bottom-up parser. We are taking the same example here. Again, the same mistake is here. I'll replace this one. Okay. Okay. Yeah, right. The same production, E plus T. T produces T star F for F. F produces open parenthesis T or ID. The same string we are obtaining. Now we are taking string, handle, and the action is reduce. Have a look at this. ID1 star ID2 so that I can separate the IDs. So we are taking. Now the handle is ID. Actually, this is supposed to be ID2, no issues. ID2 because we need to do it from rightmost way, correct? We have a production to replace it because F is producing ID. So we replace the ID by F. Next production we have is, so we have this F star ID remaining in our string. Now the handle can be F. F can be replaced by T. T produces F, right? And what we remaining is T star ID is remaining. Again, we are not doing RMD, we are obtaining LMD, right? So we shall see the RMD way also, find no issues. Now the handle I am taking is ID. We have a production F produces ID, so we are replacing that by F. So what is remaining in the string is T star F. We have a production T produces T star F, so we can replace the T star F by T. Now the handle alone, only one symbol, that is T. We have a production that E produces T, so we are replacing E. So we got the start symbol and the entire string is consumed. We are left out with only start symbol. So it is a accepted grammar or successful parsing. This is how we can do the bottom-up parsing, but the only difference is that we have started with, means we have obtained the LMD, but we are supposed to obtain the rightmost derivation. Fine. Okay, proceeding further. So all bottom-up parsers are implemented by using a technique called as shift reduce parsers. This is what is the actual thing that we're going to understand, and that's what we're going to implement. All bottom-up parsers, I'm repeating again, all bottom-up parsers are shift reduce parsers. What the idea? All bottom-up parsers. There are actually some 3 different bottom-up parsing algorithms. We'll be implementing the SLR, which is the most widely used, simple one. That's what is the thing. Okay, fine. In SR parsers, we use stack, input buffer, and the action. Means we're going to have the symbols on the input buffer, and we use stack to derive the string or parse the string, and until we'll do this until we obtain the start state of the graph. Fine, that's what is it. Okay, we use a dollar symbol where we use it in both stack as well as input buffer. This dollar symbol indicates the bottom of the stack, and the input buffer it indicates the end of the buffer. End of the input buffer. So dollar is both used in stack as well as the input buffer. So we use a dollar also in top-down parsing, where when we found the follow, so that it indicates the stop of the parser. But here the dollar has a different purpose. Yes, we're going to see that also. Okay. Now see the example. When you start parsing, that's what we call it as initial state. What will be there in the stack and the input? That's what is been shown here. The stack will going to have dollar, which is indicating the bottom of the stack. Input will have dollar preceded by the input symbols. That is a string that is given for parsing, right? So what the top of the stack and top of the input, depending on that, we're going to see what is the action to be performed. Please understand, the top of the stack and the top of the input, based on that the action will be decided. Okay, the final state of the parsing is going to be, we're going to have, and this is an accept state. Please observe, the stack should have the dollar followed by S. S is the start state of the graph, and the input should be empty, means to say it should contain only dollar. No other grammar symbols should be there, right? This is the initial state of your parsing, and this is the final state of your parsing, and successful parsing. If it is not a successful parsing, it will not be a successful parsing either if you have any other symbol apart from the start symbol on the stack, or else you don't have the start symbol on the stack, but you still have some input symbols remaining on the input buffer, then we cannot call it as a, what you call, accepting state. These two cases will going to be treated as an error case. These two will be treated as an error case. Okay. So where W, the input, is an input string, and S on the stack after final state is called as, S is the start state. Okay. Okay, fine. We shall do it according to this. But before that, we shall see how the SR parsing works. SR parser operates by shifting 0 or more input symbols, but usually or precisely will be pushing one symbol at a time, not more than one. Okay, onto the stack. That's what we call it as shift action. Shift it from input buffer to the stack, until this shift will going to be doing until handle is open, so that we can replace this handle by a appropriate non-terminal if we do have a production in our grammar, right? Okay. The parser then reduces the handle by the non-terminal by using appropriate production. The parser repeats this, keep on repeating it until we have considered all the input symbols, and also we don't, means we got a start state, then it is an accept state. If not, if you have the input empty, or either you have a input symbols or there is a start state is obtained, any of these combination of cases we're going to be calling it as an error case. Okay, so because of these reasons, we have four stages in, or four states in our SR parser. First one, shift action, wherein the next input symbol will be shifted from the input buffer to the stack. Second is reduce. You have an appropriate handle on the stack that can be replaced by a non-terminal. That's what we call it as a reduce action. Just like earlier with we had an ID, we replaced it with F. We have an D into F, we replaced it with D. So all these examples we're going to be for the reduce action. Right. The next is accept. When we have the start state on the, when we have the start state on the stack and the input is empty, then we call it as accept state. and any other combination of this. Either you have symbols on the input buffer and you have a start state, or else you didn't obtain the start state, you have obtained any other state, but you have consumed the input, then it is called as error state. So these are the four possible actions or four possible states that is possible in the shift reduce parsers. Okay, we have different algorithms to implement these particular things. We shall see them level by level. Okay, yeah. Now see the example. Same grammar G produces. Sorry again. It's actually supposed to be E. Okay. Grammar is same. E produces E plus T or T produces T star F or F produces open parenthesis E or I. Our ultimate aim is that when you have given a proper string, we should end up at E on the stack and all the input symbols on the uh, input buffer should be consumed. Yeah, this is how we're going to be doing it. We have taken a bit different string, ID plus ID star ID. Now this is the actual way the parsing will going to happen. So initial state stack is having only dollar, they are marking the end of the input, and then the input is terminated by dollar. ID plus ID star ID is what is the thing what we have. Action, first action we're going to take is shift. Obviously when we start parsing, we should move a symbol from input buffer to the stack, and that is the usual action. Until we don't have a substring on the stack, we cannot reduce. Fine. Shift ID, that's what we have did. So I got ID on, and you can observe that I have marked the initial state and similarly the final state later in a different color so that that can differentiate the thing. Okay, please observe. When I shifted the ID is taken out from your input and is placed onto the stack. Now on stack, your handle is ID. Do I have appropriate production to replace? Yes, I do have. 1 second. This is small typo mistake is there, so that I am doing it. Yeah, for a second. Ah, so action shift ID. So I got ID on this particular stack, and yes, we have a production that produces ID. That is F. F produces ID. Okay, the action is reduce. Now you can reduce by which handle is ID that can be replaced by F. Okay. Sorry, here again E has come. Okay, 1 second. Be there. Here are many places we have made a mistake. Reduces ID. Oh no, it's correct actually. 1 second. Yeah, here produces ID. Yeah. Okay. Mistake. Okay. Shift reduce action has gone wrong. Okay, I shall continue this later. I'll stop here because the animation went wrong. So I'm going to stop here. I'm going to continue this later. So thank you for joining.